All right, guys, you should already have your bell ringers out and you should have already defined a numerical expression and a diagram. So who can tell me what a numerical expression is? Brittany?
Mathematical phrase that has numbers and operation symbols.
Yeah, so it's just going to be one expression. What can we think of that has numbers and operation symbols? What's an expression that we can write?
Multiplication.
Yep, give me an example.
4 times 2.
Yep, 4 times 2. What else?
4 divided by 2.
4 divided by 2. What else? We got multiplication, we got division. What else is there?
4 plus 2.
Oh, we're going to use the same numbers. Okay, and one more?
4 minus 2.
Oh my goodness. 4 minus 2. All right, diagram. What's a diagram?
A picture that shows the relationship between quantities.
Yeah, so that's what we're going to be doing mainly today. We're going to make numerical expressions into diagrams. We can use number lines, we can use charts, we can use boxes, we can use circles, we can do pretty much any shape that we want to represent our expression. So if we want to represent 4 plus 2 or any of these operations right here, we're going to use one of these or some pictures and shapes to show that. Does that make sense?
Yes.
Okay. So now we're going to move on. Okay. So here we have a bunch of boxes. Okay. What is this diagram showing you?
4 times 2.
4. Okay. Well, what is it showing you? How many boxes? What do you see? We got a group here.
Groups of 2.
Groups of 2. How many groups of 2 do we have?
4.
4. Yeah. So we have one right here, right?
Yep.
We have one right here. We got this one, and we got this one right here. We got 4 groups of 2. Okay? Let's see. What do you think the number line is showing you?
4 groups of 2.
Got 4 groups of 2, but what is the number line doing?
Jumping.
It's jumping. How many is it jumping every time?
2.
Yeah. So if we have 2, and another 2, and another 2, and another 2, what operation, one of these, what operation do you think this is showing?
4 times
2. Might be able to be represented as 4 times 2, but what's the other operation that shows better? 2, if we do 2 times, would this make sense? To 8?
2 plus 2.
Yeah. We're going to do 2 plus 2 plus 2 plus 2, and that's going to equal 8. Right? Okay, so now we're going to get rid of all this. Hopefully this is in your notes. You should have labeled your notes with the date and reasoning with diagrams. Cool. Okay, so now we're going to move on. So let's pick an equation. Pick any equation you want. Expression. Multiplication, subtraction, division.
4 times 2.
4 times 2. Okay. If we do 4 times 2, we can do a number of things. We can do boxes. Okay. So how many columns am I going to have? How many columns do you think I'm going to have? 4, 2.
2.
I think I have 2 columns. Okay. I could do 2 columns. How many rows am I going to have then? 4. So 1, 2, 3, 4. How many boxes did I end up with?
8.
8. What's 4 times 2?
8.
8. So see, this is just a representation, a picture. A diagram is just a picture representing our equation. Okay, let's pick another one.
2 times 2.
2 times 2. Okay. How could we do this? How could we we do that with boxes?
Yeah.
Yeah? Want to do boxes? Okay, how many rows am I going to have? 2. How many columns am I going to have?
2.
Yeah. How many boxes do I have?
4.
Good. And how do you know it's 4?
Times 2 times 2 is 4.
Yeah, but with the picture, how many boxes are you going to have?
4.
4, because you have to have, so if we did a question and we did like 3 times 2, okay? And I only put, let's see. And I only put 2, okay? Does this equal 6?
No.
No. So we got to make sure, and what if I do this? Does 3 columns equal 6?
No.
No. So we got to make sure that we have 3 groups of 2 or 2 groups of 3. That makes sense.
Yes.
Okay, so now we're going to do a little bit of addition. Let's pick 2 numbers.
7 plus
7 plus
3.
3. 7 plus 3. Want to use circles, squares, stars? What do we do?
Doesn't matter.
Okay. So for this one, we're going to represent it now. Addition is a little different. We're going to do it with circles this time. You can do any shape you want. So how many circles am I going to need?
7.
Okay, I'm going to need 7 on this side. 1, 2, 3, 4, 5, 6, 7. And then what do I need to put in the middle?
Plus.
Yeah, the addition sign. Because what if I put a minus sign? Would that be right?
No.
So what do I need over here?
3 circles.
3 circles. Okay, so if we end up counting up all the circles, how many will we have? 2, 3, 4, 5, 6, 7, 8, 9,
10.
10. Okay, let's do a subtraction one. Got numbers? Let's do 6 minus 4. Okay, how many circles am I going to need? Or squares? Let's do squares.
6.
Going to need 6 squares. 1, 2, 3, 4, 5, 6. Whoa, that's not a square. Okay, then we're going to put our subtraction sign because we have to have our operation symbol. How many am I going to need over here?
4.
4. Okay, so then if you end up subtracting this, if you end up subtracting the 4 from this side, okay, this is just giving us a picture, but if we were to do it, we would need to subtract 4 from this side. So 1, 2, 3, 4. Okay, how many are we left with?
2.
2. Let's do another one of those really quick. Hey guys.
Hey, how's it going?
Good. We're just doing a video really quick. We'll be done in a minute.
Oh, I'm not worried. I'll be back.
Okay, so let's do another subtraction one. I'll show you a different way to do this. So let's do 4 minus 2. Okay, so how many boxes do we need to start with?
4.
4. We have 1, 2, 3, 4. And we're getting rid of how many?
2.
2. Let me get rid of 1, 2. How many am I left with?
2.
2. Okay, so that's just how a diagram can kind of represent the relationship between 2. Let's go to a number line really quick. Run a number line. Let's do okay, so this is 12. You gotta have 0, of course. Okay, so if I wanted to represent 3 times 4 equaling 12, what would I do? Jump.
Jump 3 numbers 4 times.
Yeah, I'm gonna jump. Well, yeah, I could do that. Or what's the other way we could do it? You could probably jump 4 numbers 3 times. So there's 2 different ways to do it. So let's do We're gonna jump to 4. Here's 1, right? We have a 3. Let's do 1, because then we won't lose count. Okay, and then we're gonna jump another 4. Where are we gonna land? 8. There's our second one. How many are we going?
3.
Okay, and then where are we gonna land on the last one?
12.
12. Okay, do you see how this is represented by this? Good. Okay, so now get out your whiteboard, and we're gonna go through a few problems, and you're gonna write down a diagram and hold it up on your whiteboard. Okay, so let's do one for 3 plus 6. You can use circles, you can use squares, you could probably use a number line. All right, hold it up when you're done. Perfect. Good, and how did you get that? How'd you get 9?
Because 3 circles plus 6 circles is 9 circles.
Good job, yeah. Like your thinking. Okay, let's do 3 times 2. Oh, all right. So everybody look at this one. What Brittany has, if we can see, is we're representing 3 times 2. She has 3 boxes on one side and 2 boxes on the other. How many boxes do we have all together? 1, 2, 3, 4, 5. Is 3 times 2 5?
No, it's not.
No, but that's all right. So let's try that one more time. Remember the columns we did, or groups. So another way you guys could do it is 3 groups of 2, right? So if we have 2 here, 2 here, and 2 here, we just make them 3 big groups, right? Because then how many groups do we have? Our 3 groups and 2 in each. So we have 1, 2, 3, 4, 5, 6. Good, yeah, or you could use it this way. Yeah, I like this way. So that's easier to represent. All right, so now you guys are gonna follow in with your individual work time, which is a worksheet. Okay, on this left column, you're going to sketch a diagram for each of the following ones. You can use your circles, your squares, your charts, a number line. And then on the right side, you're gonna explain what the diagram shows. So like on the first option, if we can see this here, we have circles. So we have 3 circles on the top and we have 3 circles on the bottom. Okay, how many circles do we have all together? 6, so it's probably going to be what operation?
Multiplication.
3 times 3 is 9, so it wouldn't be multiplication.
Adding.
Yeah, addition. All right, so you guys can go ahead and get started on that.